Alright, pre-calc, so our next unit is going to have 3 or 4 videos. The first one is going to be about sequences and summation notation. So some stuff you've seen in Algebra 2 and definitely in FST if you took that class. So today we're going to talk about evaluating a specific term and then what recursion formulas mean. And finally then we'll do our summation notation and then the reverse using summation notation or writing sums in summation notation. So first piece, if we talk about a sequence, basically what that means is a series, or it is a list of numbers where we have a domain, meaning these are going to be x values, and in this case you're going to see the letter n quite a bit, and they're going to be the set of all positive integers, meaning we're just going to start with 1, 2, 3, and so on. So in an infinite sequence, we're going to have 1 to infinity, the domain is unlimited. In a finite sequence, then you would be given n integers, so you could maybe say n is 4, and so you would have 1, 2, 3, and 4, and that would be your domain. Okay, so first part, if we talk about our notation, a sub n just means it is the nth term of the sequence, and so we could find that specific term based off of some formula we may have. An example here, we have a sub n equals 3n plus 4. So that means, if we're looking for a sub 1, we're just taking 1 and plugging it in for n. Our a sub n here kind of has replaced f of x. So if we do these 3 values that we have here, a sub 1 we can plug in and we would get 7, a sub 2 we'd plug in, we would get 10, and then if we wanted to find a sub 54 for some reason, we would plug in 54 then, and we'd end up with 166. We're just taking these subscripts, these 1s, 2, and 54, and plugging them in for n, and that is going to be the value of the 54th term, or the second, or the first. We could do that for any number we had. Changing gears a little bit, a recursion formula, then we can't just find any term because it is a sequence where each term is based or defined or found by using the previous term. And so you'll be given the first term and then a formula for the nth terms. So suppose we have some term a sub n, then the previous term would be written as a sub n minus 1. And the next term we could say is a sub n plus 1. And so we're always going to need our a sub n minus 1 to find a sub n. Here we have an example, your first term and then your recursion formula. You notice this is a lot different. We don't just have the letter n. So to find a sub 2, we need to know a sub 1. This would be 3 times 5 plus 2, which obviously gives you 17. Now to find a sub 3, you have to use a sub 2, the previous term. So we'd say 3 times 17 plus 2. And if we plug that in, we would end up with 53. A sub 4 would be same idea. 3 times a sub 3, which is 53, plus 2, and we could sort that out and find our value for that. Okay, the next piece then, so we're moving pretty quick, the summation notation. This just means we're going to have n terms, and we're going to start with 1 and go by integer values, 1, 2, 3, all the way up until we get to whatever our last term is. This symbol right here is called sigma, and that just means you're going to find the sum of some formula here. A sub I here just represents some algebraic expression for which we'd be plugging in the values of n that we're given, where we start here and where we end at the top. An example, then you see we start at 1 and we're going to end at 6, which means we should have 6 terms. 1 for I equals 1, for I equals 2, 3, 4, 5, and 6. And we're going to find all of those. So if we plug in 1, we're going to get 2. Plus, if we plug in 2, we end up with 5, plus 3, we end up with 10, plus 4, we end up with 17, plus 5, we end up with 26, and 36. 6 is going to end up with 37. So all I did was take these 6 values, 1, 2, 3, 4, 5, 6, I plug them in, square them, add 1, and that gives me my terms. Which, if we combine all of those together, our summation of these 6 terms from 1 to 6 of I squared plus 1 would be 97. So that would be our summation. Now we can do the opposite as well. So you see here, every time we have some I cubed. And we're going from 1 to 7. So I'm going to write my sigma, hopefully. Write my sigma, okay? And we see that I starts at 1 and it ends at 7, and each time it's cubed, so that tells me it's just I cubed. And then we could actually find the summation of those if we wanted to as well. So, bonus points for tomorrow as we near the end of the year here. Explain on a half sheet of paper without a calculator how you could figure out 900 factorial over 899 factorial. And the way you're going to do that, remember this is a factorial symbol. Remember what that factorial means and see if you can simplify that to tell us what it is. All right, that is it for this lesson. Went over a lot in a short period of time. We'll see you next time.